For part 2, we need to do the same thing again. So start off by differentiating. Now we've got a quotient here, so I'm going to use the quotient rule, which is u dash v minus uv dash all over v squared. So differentiate the first one, leave the second one alone, minus leave the first one alone, and times by the differential of the second one, all divided by the bottom one squared. I can simplify this x squared times 1 over x to just an x. To give me that. Again, we want to make this equal to 0 at the stationary point. And if this is going to equal 0, we need the top to be 0. I can factorise an x out. So again, I can say that either x equals 0 or 2 ln x take 1 equals 0. But if x equals 0, then I'm going to be doing an ln of 0, and that can't happen. Definitely can't happen because I'm going to have ln 0 on the bottom. So again, that's not a possible solution. So the only solution is going to come from here. If I add 1 to both sides, I've got 2 ln x equals 1. So ln x equals a half. These are equal signs. My pen's being funny. They're not inequalities. Anyway, if ln x equals a half, we need to remember how to get x out of that. And what you need to remember is that if y equals e to the x, then x equals ln of y. Here we've got ln of x equals a half, so this is like, this matches here, this x here matches with this y here, and this half here matches with this x here. So our y and our x there, we're going to have that x equals e to the half. That's in exact form, so we can stop there.